Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we will present about Leg 4, Transmission Line, No Load and Matching Independence. From the team, Muhammad Zahir, NASRULLAH ZIKRI and Muhammad AMIR Syahir. Okay, next go to the procedure. Procedure for no load circuit. First, set up the no load circuit as illustrated in figure 1. Then, disconnect the resistive load to study operating response under no load. Okay, next, for both line legs, set the voltage to the nominal value 380 volt. At the beginning of the line, the outer conductors are designed L1, L2 and L3, the neutral conductor. Measure the variables indicated in the table. Okay, next, record for the following result.
Okay, for the result we obtain from table 1, no load circuit for line length of 115 km. For voltage line 1 to neutral at line start is 219 volt. For voltage L2 to neutral at line start is 280 volt. For voltage line 3 until neutral at the line start is 221 volt. Voltage for L1 to L2 at line start is 378 volt. For voltage L1 until neutral at line N is 221 volt. For voltage L2 until neutral at the line N 221 volt. Okay, for active power at the line start is 0 volt and reactive power at the line start is negative 91 var. So we go to the result.
Okay, for the electrical schematic diagram, for no load for 150 km from power supply, we use for first phase we use brown 3-phase line. For wire we use brown, and for second black wire, and third silver wire, and neutral and ground for the instrument. And then it connect to power quality meter sending, and then power switch module, and then transmission line model for 150 km. For 150 km we use capacitor 3 times 150 and farad. And for the long this connection 3 times 0.55 microfarad. And then for the ohms resistance we use 3.6 ohm. And then for the inductor 150 millihenry. And then repeat again, use 3 capacitor times 150 and farad, and 3 times 0.55 microfarad. And the neutral on the adding, and the adding we use capacitor resistor 7.5 ohm, and for the inductor 0 millihenry. And then connect with power quality meter receiving. And then for the resistive load, for no load circuit, we not connect the wire at the resistor. So when we change the value, is not respond in that function. Okay, alright.
Okay, this is for result for no load circuit for line length of 300 km. You can see the result is little bit different from 150 km. You see the result is more than result table 1. Okay.
Okay, for the electrical schematic diagram, no load circuit for 300 km, the difference is at the transmission line model 300 km. It's increase the value increase that we use of the load in transmission line model. Like for capacitor we use 3 times 300 and farad before the capacitor and before the resistor, and the resistor 7.2 ohm, for the inductor 230 mAh, and then 3 times 300 and farad, and then for the long circuit that connect the 3-phase L1 L2 L3 to a DIN, we use 3 times 1.1 microfarad, and then for the DIN use resistor 15 ohm, and then inductor 200 mAh. Alright, and then connect to power operating meter receiving, and same like 150 km.
Okay, for the question, for the no load, why the result of line voltage at sending and receiving end little bit different in case 150 km medium transmission line, but obviously different in the case of 30 km long transmission line? For the answer is this, because when the line length increase, the reactance also increase. It is directly proportional. It result to voltage drop increase and the receiving end voltage decrease. So that's why. Okay, for the next question. Okay, for the question 2, compare the measurement result with the calculated value, then mix your summary based on comparative analysis. For the result for 150 km, based on the measurement and calculate result we obtain, we can say that the line voltage in calculation for line 1 is 220.5 volt, while in measurement the voltage is 219 volt. The current in calculation is also half of the measure is 0.07 ampere, and for the calculate 0.14 ampere. For the reactive power, we can see the measure is 91 var, and for calculated is 19.7 var. There we can see this is almost no different in the reactive power. Okay, for 300 km, based on the measurement and calculated result obtained, we can say that the line voltage in calculation for line 1 is 220.5 volt, while in measurement the voltage is 220 volt. The current in calculation is also half of the measure is 0.145 ampere, and for calculate is 0.28 ampere. For the reactive power, we can see the measure is 190 var, and for calculate is 181.4 var. There we can see they have a bit different in the reactive power.
Okay, for the procedure for matching under load circuit, first to study the response during matching, the resistive load is decreased from its maximum value until attainment of the power levels is specified in the table below. Then, in the case of both line length, the nominal voltage 380 volt is to be set at the start of the line and maintained at this value for adjustment whenever necessary. Next, the variable indicated next are to be measured. Then, record the following result and detail.
Okay, for the result we obtain for table 5, matching rig circuit, line length 150 km. Active power of load is 555 watt. For voltage L1 until L2 receiving end in volt is 368. For current L1 0.87 at the receiving end, and for current line 1 line sending end is 0.87, and active power line ending 573. For the active power is 2 var.
Okay, for the electrical schematic diagram, machine circuit for 150 km. The difference is at the resistivity load that we connect the resistivity load to get the same value current from power quality meter sending and power quality meter receiving. And for the value in transmission line model, like the same for no load machine circuit, the same value for the capacitor 3 times 0.55 microfarad and 3 times 150 farad, and for the resistors also same 3.6 ohm, and value for inductor 150 millihenry, and for capacitor also same. And for adding same with load no load circuit 7.5 ohm and 100 millihenry. Alright.
Okay, for the table 6, for line length 300 km, for active power of load, natural power in the case is 547 watt. Voltage line 1 until line 2 receiving end is 366 volt. For current line 1 for receiving end 0.87 ampere. For current line 1 line sending end 0.88 ampere. For active power line sending end is 565 volt, and reactive power line sending end is 3 var.
Okay, for the electric schematic diagram machine circuit for 300 km, also same. It different if at resistive load we connect the load at resistive load, and to get like the value of power quality meter, it also same with power quality meter sending with receiving, which is 0.87 and 0.88 ampere. And then for question,
For the fourth question, what can you suggest the result in medium transmission line 150 km and long transmission line 300 km? Based on the result on table 3 and table 4, we can say that apart from voltage drop, all the other reading for current, active power and reactive power increase as the transmission line increase in length for 100 km to 300 km table separately. So question 2, compare the measurement result in medium transmission line and long transmission line. The answer is the voltage drop on a long transmission line is greater than on a medium transmission line. Long transmission line have a larger independence. Next question. What is the relationship of those results in table 5 and table 6 corresponding to the matching independence issue? Based on the result in table 5 and table 6, the relationship is corresponding independence issue is that the reactive power is demand by the load. Okay, 2. Compare the measurement result in medium transmission line and long transmission line. According to table 5 and table 6, active power of the load and reactive power have the highest reading when the transmission line length rises, but current increase slowly when the transmission line length increase, but voltage decrease as the transmission line increase. For the conclusion, from this lab we able to identify the characteristic parameters of lines operation under no load, during matching and during symmetric. Then we also learn on how to length the transmission line affect the reading output, which can be conclude to the when the length of the transmission line increase, the reactance and the voltage drop also increase proportionally at the transmission line. Okay, that's all from us. Thank you.
alright.